All right, so in the last video we were talking about polynomials, and we talked about different features of polynomials, and really we laid the groundwork for what we're going to be doing in this section, which is graphing polynomials. So let me go ahead and put up our title here. So there's 4 problems I'd like you to do. There's 2 on this slide, and then there'll be 2 on the next slide. Let's see what you remember. Now on part C, that's something we haven't talked about, so I'll mention something there. But you should certainly be able to do A and B. All right, so let's go ahead and look at these. So we have f of x equals x squared minus 2x minus 24. And the first thing we need to do is find the maximum number of real zeros that the function can have. And what we learned is it's the degree of the polynomial. So in this case it would be 4. Now if there's 4 real zeros, then we will have 4 intercepts. So we can have at most 4 X-Intercepts. And now let's talk about this thing about turning points. Now you can look at several graphs of polynomial functions, and again you see a pattern with turning points. So basically if the polynomial has a degree of n, there's going to be n minus 1 turning points or less. So basically n minus 1 turning points at most. Let me go ahead and add the at most there. Okay, so in this case, since our degree is 4, that would be 3. All right, so on problem 2 here, you have g of x is equal to 3 plus 4x minus 5x squared plus x cubed. And so here, our degree is 3, so we can have at most, or the maximum number of real zeros would be 3. And if they're all real zeros, we could have 3 X-Intercepts, but we have at most 3. And since the number of turning points will be 1 less than our degree, that would be 2. All right, let's move on to the next slide. It says use the leading term test and your knowledge of Y-intercepts to match each function with its graph. Excuse me. Honestly, you can look at Y-intercepts. Here it would be 0, 36. Here it would be 0, 108. But I think the thing we really want to look at here is the end behavior, and that should be enough. But sometimes the Y-intercept can help us out as well. So first of all, we want to know, let's see, on number 3, our degree is 4, because our leading term has a degree of 4. And our coefficient is positive, so basically we have an even degree and a positive coefficient out front. In this case it's actually 1. And so the end behavior here is going to look like the end behavior on this graph here. Basically it opens up, or I should say it rises on both ends. If we look at number 4, the degree is 3. This time we're odd and the coefficient out front is negative. In fact, it would be negative 1. And so this is the reverse John Travolta in behavior, or basically f of x equals minus x cubed. It's like that, which that happens to be our leading term, and so that would be the other graph. So a lot of times we can identify the graph of a polynomial function just by looking at end behavior. All right, so let's go ahead and get started on graphing functions. In this first problem, I'm going to take you through 5 steps, and then after that, we're just going to do the problem completely, but you'll need to use these key steps. All right, so it says use the leading term test to determine the end behavior, find the zeros. Any real zeros correspond to X-intercepts on its graph. Determine the behavior at each zero. Number 4, find the Y-intercept. That's probably the least important one of the bunch. And then 5, we draw the graph. If we need to, we can find additional points. You can always do that by just plugging in some x values. All right, so let's go ahead and get started. So it says in the first box here, we need to find the degree. Well, the degree of this is a little bit harder to see, but if you actually add the exponents on our variable factors, that'll tell you the degree. So the degree here is 3. You're just adding 1 and 2. So describe the end behavior. Notice we're odd, and the number out front, it's actually just a 1 here. And so we're positive, and so the end behavior looks like this. It's what I call the John Travolta end behavior. It's like y equals x cubed. Next, we need to find the x-intercept and the behavior at the intercepts. Well, let's see. We know that -2 and 1 are zeros since x plus 2 and x minus 1 are factors. And let's go ahead and make a z and b chart. Remember, z is for 0, m is for multiplicity, and b is for behavior. In other words, the behavior at the corresponding x-intercept. All right, so let's go ahead and put in our zeros. And notice the exponent here is 1, so our multiplicity for -2 is 1. And here we have an exponent of 2, so our multiplicity for x equals 1 is 2. And we know that our multiplicity, if it's an odd number, we're going to cross at the corresponding x-intercept, which in this case is -2, 0. And when x is 1, and our multiplicity is 2, so that makes the behavior at the x-intercept, we're actually going to bounce. So we're going to bounce at the point 1, 0. The y-intercept can easily be found by just finding f of 0. And so we're going to get 2 times -1 squared. Well, -1 squared, that's what we need to do first here. That's 1. Times 2, we're going to get 2. And so the y-intercept is the point 0, 2. So now we have all the information we need to draw the graph, or basically to draw a rough sketch of the graph. Excuse me. So first of all, let's put in our x-intercepts, and then we'll put in our end behavior, which is going to look like that. And then I always work from left to right, and as I get to the x-intercept, I just follow my directions here. So when I get to the point -2, 0, I'm going to cross at that point, and then eventually I'm going to have to come back down and go through the next intercept where I'm going to bounce. So we bounce when we get to 1. All right, so these are the steps you're going to go through as you do the problems on the next several pages. And you know, in this problem it was in factored form, so if it's not in factored form, then we'll have to factor as part of that process. All right, so on number 6, we can identify our zeros just by looking. Notice our degree is going to be 4 plus 2. We're just adding, we're just adding our exponents on our variable factor, so 4 plus 2, which of course is 6. And so we're even and negative. The coefficient out front is -2, so even degree, negative coefficient out front. And so our end behavior is going to look like this. It's going to open down, or I should say the graph's going to fall on both ends. Our zeros are going to be 0. If x is a factor, here we have x to the 4th, then 0 is going to be a 0. In fact, if you plug 0 in here, -2 times 0 to the 4th is just 0, and 0 times whatever else is going to give you 0. So 0 is a 0 of this function. When you plug it into the function, it will 0 it out, or cause it to equal 0. And of course, -3 is also a 0, so let's do our z and b chart and put in our zeros. Our multiplicity for 0 is going to be 4, the exponent on x, which is 4. And the multiplicity of negative 3 will be 2 because x plus 3 has an exponent of 2. And so in both of these cases, our multiplicity is even, and so we're going to bounce at these corresponding x-intercepts, which would basically be 0, 0, and negative 3, 0. Now I'm going to erase those just because I'm going to need that space later. So we're going to start our graph by plotting our zeros, or our x-intercepts, and let's put in our end behavior, and then we'll work left to right. When we get to negative 3, we're going to bounce. That means we don't cross, we come back down. Now we don't know how far we're going to be going down here. That's something that calculus can tell us, but we know eventually we're going to have to come back up to the x-axis, and we'll bounce when we get to 0. All right, so let's move on to number 7. In fact, I would encourage you to try number 7 before you watch the video. All right, so our degree is going to be 6 again here. It's going to be 1 plus 2 plus 3. Again, we're just adding our exponents here. And so we do get 6. And so we're even. And notice the coefficient out front is 4. And so we're positive. And so this graph's going to rise on both ends. And our zeros are going to be 0, 5, and negative 3. So let's make a ZMB chart and put in our zeros. So our multiplicity for 0, well, it's x to the first power here. There's only one factor of x, so that would be 1. For 5, it's going to be 2, and for negative 3, it's going to be 3. Again, that's because this factor has an exponent of 3. And so if our multiplicity is 1, we're going to cross. When we have a multiplicity of 2, we're going to bounce. Multiplicity of 3, so we're odd again, we'll cross. So again, if it's even number, we know we're going to bounce. If our multiplicity is odd, we're going to cross. So let's go ahead and put in our points and our end behavior. And when we get to negative 3, we're going to cross. And then when we get to 0, we're going to cross. And then when we get to 5, we're going to bounce. And by the way, if you get to this last step and it doesn't match your end behavior, then you obviously know you've made a mistake. All right, let's move on. All right, so on number 8, notice we're going to have to factor this one. But before we do that, you can see our degree is 3. And so that makes us odd degree and positive, which means our end behavior looks like that. And if we set the function equal to 0, we can find our zeros. Now the first thing I'm going to want to do is factor out an x squared. It's going to be x squared. Let's see, I need x squared times x to get x cubed, and x squared times a minus 6 will give me the minus 6x squared. And so I have two factors here, x squared and x minus 6, and so my zeros are going to be 0 and 6. So let's go ahead and make a ZMB chart. And so again, our zeros are 0 and 6. Our multiplicity for 0 is going to be 2. Notice again we have an exponent of 2 on x there. Our multiplicity for 6 is going to be 1. Again, there's an exponent of 1 there. And so at 0, 0, we're going to bounce, and at 6, 0, we're going to cross. Let's go ahead and put the points on the graph and the end behavior. And so when we get to 0, we know we're going to bounce. Eventually, we'll come back up and we'll cross, which matches our end behavior, and so we're good. So again, I would encourage you to maybe try number 9. You may have some problems with that minus out front. All right, let's look at this. So our degree is 3, and notice this is an odd degree, and our coefficient out front is negative. In fact, it's negative 1. And so our end behavior is going to be what I call the reverse John Travolta end behavior. It's really y equals minus x cubed in behavior. And so we need to set our function equal to 0 to find the zeros. We're going to want to factor out a minus 1, or really a minus x. And so it'll be minus x times x squared, a minus x times a minus 5x, and a minus x times a plus 4. And so that's what we get when we factor out a minus x. And now we can factor this part in here. So I'm going to go ahead and set it up. I know that I'm going to have x and x here, and I need two numbers that multiply to 4 and that add up to negative 5. And so the numbers that work there are going to be negative 1 and negative 4. And so we're going to get zeros of 0, 1, and 4. Let's go ahead and do a Z and B chart. Put in our zeros. And each of these is actually going to have a multiplicity of 1, which means we're going to cross at each of our X-intercepts. So let's go ahead and put in our X-intercepts and the end behavior. And we're going to cross at each intercept. So we're going to cross. We don't know how far we're going to go down, but eventually we have to go back up and we'll cross. And again, we'll come back down and we'll cross. Notice that that does match our end behavior there, so we're good. Let's move on to the next slide. All right, so on number 10, it's actually a lot like the one we just did, except for you're going to have to factor by grouping. So you might try it and then watch the video, or if you get stuck, just watch the video. So let's see how you did. So first of all, our degree is 3. So our degree is odd and we're negative. We know that's the same end behavior that we just had, the reverse John Travolta. And so now we're going to go ahead and set our function equal to 0. But notice I factored out a negative 1. I don't put the 1 here, but we've actually factored out the negative or negative 1. So basically all our signs have changed. But now we're just going to focus on this polynomial with 4 terms, which means we're going to want to factor by grouping. And so for the first 2 terms, we can factor out an x squared. So it'll be x squared times x plus 3. When we look at the last 2 terms, we expect an x plus 3 factor, just like we had in the previous 2 terms. And you can see that a minus 9 times that would give us negative 9x minus 27. So our common factor is x plus 3, and if you cross out your x plus 3's, you can see the other factor is going to be x squared minus 9. So finally, when we factor this, we get x plus 3. Now this is a difference of squares. We would factor this as x plus 3 times x minus 3. So now I'm going to bring down that negative that's always been there, and don't forget this has been an equation. So we have minus the factor x plus 3 times x plus 3 times an x minus 3 equals 0. I could have written that as x plus 3 squared. So now we can say our zeros are negative 3 and 3. So let's do a Z and B chart and plug in our zeros. The multiplicity, now notice there's 2 factors for x plus 3, so the corresponding 0 would have a multiplicity of 2. And there's only 1 factor of x minus 3, so for 3 our multiplicity is going to be 1. So at negative 3, 0 we're going to bounce, at 3, 0 we're going to cross. Let's go ahead and put in our zeros, or our x-intercepts, put in the end behavior. And so when we get to negative 3, we're going to bounce. Eventually we have to come back down, and notice we could put in the y-intercept here, but it's actually 0, 27. So you can see that you know, that could go up awfully high. I mean, it could have gone down real low. That's something, again, that we'll study more when you get into a calculus course. But for our purposes, we're just drawing a rough sketch. We know it's going to come back down and it's going to cross at 3. And so your graph's going to look like this. And again, at your peaks or any valleys, which we don't have here, we're just estimating or approximating. We're really not even trying to do that. We know here it's eventually going to come back down, but we don't know how high we go. All right, so number 11, I would again encourage you to try it and then watch the video. So our degree is 4. It's an even degree, and we're positive out front, and so our end behavior is going to be like that. We're going to rise on both ends. So let's set x to the 4th minus 9x squared equal to 0. So set the polynomial equal to 0. Let's factor out an x squared. We get x squared times the quantity x squared minus 9 equals 0. And of course we have a difference of squares there. We can write this as x squared times x minus 3 times x plus 3 equals 0. So our zeros are going to be 0, 3, and negative 3. So let's make our Z and B table and put in our zeros. The multiplicity for 0 is 2, since x is squared. And our others are both going to be degree 1, since our exponents are 1. And so at 0, 0, we're going to bounce. At 3, 0, and negative 3, 0, we're going to cross. So let's go ahead and put in our points. Our end behavior, we know it rises on each end. And so let's see, we'll start on the left. So when we go through negative 3, we're going to cross. Eventually we have to go through 0, 0, and we're going to bounce. And we'll come down, and then eventually we'll have to come back up and go through and cross at 3, 0, which matches our end behavior, and so we're good. So I think you're probably in pretty good shape if you understand what we've done so far. If you want to practice a little bit more, you can do the next 2 problems. All right, so if you did do these problems, let's see how you did. So our degree here is 4, and that means we're even and positive, which means we're going to rise on both ends as far as end behavior is concerned. Let's go ahead and set our polynomial equal to 0. We have x to the 4th minus 3x cubed plus 3x squared equals 0. Now we can factor out an x squared. It'll be x squared times the quantity x squared minus 4x plus 3, and that's equal to 0. And we're going to want to factor this trinomial here. And so, whoops, let's set it up. We have x and x. I need 2 numbers that multiply to 3 and add up to negative 4. That's going to be negative 1 and negative 3. And so our zeros are going to be 0, 1, and 3. So I'll do a Z and B chart and put in our zeros. Our multiplicity for 0 is 2. And notice for the other 2 zeros, we're going to have a multiplicity of 1, which means at 0, 0, we're going to bounce, and at the other 2 zeros, or X-intercepts, we're going to cross. So let's go ahead and put in our X-intercepts and our end behavior, which again rises on each end. So when we get to when we get to 0, we're going to bounce because our multiplicity is even. And then when we get to 1, we're going to cross, and then we'll also cross at 3. All right, so that's number 12. Finally, on number 13, our degree here is 3. So that means that we're odd degree, and the coefficient out front is positive, that positive 2 out front. And so we're going to have the John Travolta end behavior. It's going to look like y equals x cubed. Falls on the left, rises on the right. Let's go ahead and set our polynomial equal to 0. We have 2x cubed plus x squared minus 8x minus 4 equals 0. So in the first 2 terms, we can factor out an x squared. We get x squared times the quantity 2x plus 1. When we factor our last 2 terms, we can expect to get a 2x plus 1. And negative 4 is what's going to work there. So notice negative 4 times 2x is the negative 8x, and negative 4 times 1 gives us the minus 4, so that does work. So we have two terms with a common factor of 2x plus 1. So it's going to be 2x plus 1 times x squared minus 4. So we end up with 2x plus 1 times x minus 2 times x plus 2 equals 0. Now to find our first 0 here, you might want to set 2x plus 1 equal to 0. And when you do that, you'll subtract 1 on both sides, divide by 2, you get x equals negative a half. So our zeros are going to be negative a half, 2, and negative 2. Let's go ahead and make a Z and B chart and put in our zeros. And in fact, at all of our zeros, notice our exponents are all 1 here. And so our multiplicity will be 1, which means we cross at each of our zeros, or X-intercepts. And so let's go ahead and plot our points and put in our end behavior. Falls to the left, rises to the right. And we're going to cross at each intercept as we go from left to right. So cross, cross, and cross. Your graph's going to look like that. All right, and that's it for this video.